All right, everyone. My name is David Gallagher. I'm with the Ohio Department of Transportation's UAS Center, and I'm pulling my presentation here, so bear with me for just a second. So I am the Flight Operations Manager for our Department of Transportation, so I do all the flight scheduling, all the risk assessments, all the flight planning, and make sure our operations go according to plan and we conduct safe and efficient operations. So just give you a little information about our program, what we do, and who we are. Again, I'm with the Ohio Department of Transportation, so we conduct all the flight operations for our host agency, the Ohio Department of Transportation. So we develop all the policies and procedures, because let's face it, this is a new disruptive technology, breaking new ground here. Not a lot of stuff on the books when it comes to UAVs, UAS drones, what have you. So we also approve third-party operations over state properties and state right-of-ways, ODOT right-of-ways. We're also external resource, shared service with other departments, just to name a few of them. Ohio Department of Public Safety, Ohio Environmental Protection Agency, Ohio Department of Rehabilitation and Correction, Ohio Department of Natural Resources, just to name a few. I'll give a couple examples as well. So if you're kind of new to this, probably all different levels of folks on this call, you might not be aware of this, but we're in the midst of an aerial revolution, the first being the propeller airplane, the second being the jet aircraft, and now electrification with these new vehicles. We're also kind of coming into a crossroads with autonomy and lithium batteries and new computing power and higher processing power. So everything's kind of coming into a group all at once here. So we expect to have big things coming over the next 5, 10, 15 years when it comes to electrification and automation of vehicles. So why do we use this new technology? Well, the first and easiest way is it increases efficiency and it increases safety. So, we save time and money when we use this technology out in the field. And basically our responsibility is to improve and maintain the transportation infrastructure. So that's what we use this technology for. So, folks from all over the world on this call. So, and at least the United States, we probably have a lot of folks from the US on here as well. So up until 2016, things were really different. Folks couldn't operate commercially really that much unless you had a 333 section that only lasted about a year. So people were only flying under the public COA. So in 2016, when FAA had the remote pilot certification, it was really things would change for us. We were able to increase our staff, be able to have quicker, more efficient operations, and we started to buy more aircraft. So you can kind of see the trends starting to spike with our organization as far as purchasing new aircraft. So our fleet really consists of, we've got fixed wing aircraft, we've got an EB plus, we have actually now 8 SkyDIO2s, we've got 4 M200s, M210s, we have 2 Inspire 2s, we have a heavy lift aircraft, the M600, which we use primarily for magnetometer. I'll give one example of that. So our major uses: aerial photography and GIS, interior and exterior inspections, construction monitoring, traffic monitoring, emergency management. We do a lot of communications and promotional videos inside of our Department of Transportation. We look at a lot of structures and facilities. So here's our flight operations summary over the last couple of years, and this is provided to us by one of our sponsors, Skyward, for this call. So we do a lot of our flight planning and our scheduling through Skyward, and I couldn't imagine doing it without them. So in 2019, we had 1,471 individual flights and 344 projects. 2020, we had 2,009 individual flights and 552 individual flight logs or flight projects. So that kind of spiked when we started getting the technology in the hands of experts. So we decided, with the way things were, we weren't able to hire new staff. So we wanted to train the experts inside the Ohio Department of Transportation. So we really got this technology in the hands of primarily two groups, even though there's more, the bridge inspectors and the surveyor folks. So we have what we call our district drone deployment program. So we get this technology in the hands of the folks that are out there doing this stuff every day. So we require them to get their Part 107 first. Then they come to our office in our center for 2 days of training. So we required at least a minimum of 3 hours of training on a UAS platform. It happened to be a Phantom 4 Pro. So sometimes it takes folks longer than 3 hours to kind of get a handle on it, but 3 hours kind of seemed like the magic number for us. So once they hit that, we issued them their own aircraft, and they're required to get 10 solo hours of training. So they went through our safety management system, our risk assessments, and our flight planning software, which goes through Skyward. So once they get proficient all this stuff, they'll go with one of our folks. We've got 4 full-time folks in our office who have their Part 107. So they go on almost like a check ride. If you guys are familiar with aviation or any pilots out there, we went through kind of a small check ride to make sure they're proficient on everything, and they're out there on their own flying. So we've got 2 bridge inspectors, 5 surveyors, 1 engineer, 2 folks from our communication shop, 1 guy out of construction, 1 guy out of our CAD mapping. So we've got 12 district folks and 4 UAS center folks out there flying on a regular basis. So one of the things that we look at primarily the most is traffic monitoring. We get called out the most for traffic monitoring. So you can see here at a recent article, a recent drone survey by the Department of Transportation Unmanned Aircraft Systems Center led to traffic signal changes done by the city of Brooklyn. So we look at a lot of traffic signals with UAS and see how we can adjust it. Other areas with traffic hotspots, I always say if it looks like a spaghetti bowl in Ohio, we're taking a look at that and seeing how we can increase traffic flows and what might be hanging up some of the traffic in those areas. Lane closures and lane shifts are another big one. If we have a lane closure, there's always traffic that's building up, a lot of accidents occur. So we want to figure out new ways we can make the traffic flow smoother through these areas. Another big one we get called to, traffic is always flowing smoothly until, what time, 3:05 when school gets let out. That really changed the dynamic of traffic flow in a given area. So we get called out to a lot of areas to assess traffic during school hours, whether it's in the morning or the afternoon. This particular one you're looking at in front of you is in the city of Springboro. They have 5 schools that are kind of bunched up close to each other. So we're able to fly 6 drones simultaneously at different locations to assess the situation and see how we could increase traffic flows. Another one we get called out to are special events, Black Friday, big increases of traffic. The net effect of that is builds up traffic on the freeway. Another one is our state fair, same thing, parking's an issue there, and also it dumps a lot of traffic, unwanted traffic onto the freeway. So we're using this technology to see how we can increase traffic flows, maybe get people parked a little quicker into these special events. Another one we look at a lot is natural disasters, landslides, and tornado activity. Here's in 2019, we had a significant amount of tornadoes that went through the Dayton, Ohio area and devastated a lot of the areas. So we partnered with the Ohio National Guard and provided all the overhead view using UAS technologies. Another one we get a lot is flooding. Flooding causes a lot of problems for us, particularly in the southwest part of the state. That leads to landslides, as you can see here. We have a landslide that we caught slipping as we were out there. So we use the technology to look at potential landslide areas. We also can use our thermal technology to see where existing landslides and areas that you could normally see with the naked eye. You could see here it shows a gap in the surface here that the folks weren't able to see by just surveying on their own. We're able to put the aircraft in the air and take a look at it and see, hey, there's something here worth checking out. Construction progress monitoring is another one we get called out to all the time, looking at various construction projects before, during, and after. Engineers want to make sure the projects are going on time, so we get called out frequently all over the state to take a look at it. Another one is bridge construction. We look at a lot of bridges. Bridges are always being repaired or new bridges coming up. So we're always looking and documenting interchanges, new construction areas, or improving existing areas. Another big one that we use here, I mentioned before, bridge inspection. The traditional methods of snooper, which are still a great method and a preferred method by some, but increasing, unless it's a critical fracture area, we use this technology to speed up the process and make it more safe and efficient. We have some areas, some bridges that we only can inspect at night because the traffic flow is so voluminous that we can't do it during the regular business hours. So we found out we can use UAS to augment some of the inspections during these busy areas. So we primarily use for looking at scour assessment, foot detailing, cracking, and delamination. Here's an example of a bridge that's really high up. You'd have to pay someone to go up there and take a look here, but we're looking at an existing crack here, and we can zoom in there and look at it without sending someone up there to see if the repair job is still holding, which we found out it was in this case. So it's a perfect example of how we're using technology. I mentioned some delamination techniques using thermal cameras. So here's an example of it here. Instead of using the traditional sounding methods, we're using a thermal camera. Here's another vantage point of it underneath the bridge here. You can really see the contrast using the electrical, optical versus thermal technology. You can really see the cracking and delamination on these bridge piers. So we kind of sought out here. Juan mentioned that we tried to do some return on investment calculations. Using a bridge inspection was an easy target for us. So we looked at this. We calculated all the labor and all the man hours it would take. So you could see here on a given day, it would cost $3,143 versus $522 to send out 2 people versus sending out 6 people to, labor that's in cost with that. Shutting down a road is very expensive to do. A lot of folks out there, not to mention we were shutting down a lane. You're inevitably causing accidents. It always happens. So there's a safety aspect you really can't put a dollar figure on. So we calculated, and this is a very conservative estimate, we're at least saving $2,621 every time we send out a crew of drone inspectors instead of using a snooper. So just a couple other examples before we move on. What we came here to talk about is some of the mapping features. This is a magnetometer we use. We dangle down with a M600. Our Ohio Department of Natural Resources are looking for abandoned wellheads. They're environmental hazards. They leak, and a couple of them exploded. So we're looking to patch these up, some of the abandoned ones across the state. So it's a very effective way of looking for abandoned wellheads. So here's another mapping. Here we go. This is an Ortho Mosaic. We had the city of Dayton, Ohio, and the Dayton Police Department. They had a situation where folks are drag racing on the strip here. You could actually see where they're kind of launching their vehicles in the middle there. So they wanted to mitigate drag racing going on. So they wanted overhead photos of where they could put speed bumps in to mitigate some of the drag racing. So basically here we're just stitching hundreds of photos together to take a look at it, and you can zoom in and zoom out to get really high resolution areas if they want to further look to where they want to put speed bumps. Ohio EPA, we're doing volumetric calculation to see what it was going to cost to remove this rubble pile. This was a company that was in the business of recycling homes. They went out of business and left this big pile of rubble that the state of Ohio was tasked with cleaning up. So they called us out there to do a volume calculation. Here's another thing that we do at the state here. A lot of times we'll want to put a new on and off ramp, and a private citizen will have a piece of property and they want to sell to the state of Ohio. So we're looking with our Ohio Attorney General office. They wanted to do a mapping of the area to see, for purchase prices and what that would look like. So here's an example of using photogrammetry and stitching photos together to put this together. A survey project, as I mentioned, we're getting a lot of our surveyors in on the drone business. So this was one of our guys in our District 5 office. He provided a traditional method of using surveying together, and he did a one with a drone just to see how to comparison. He says, yeah, everything, the accuracies are where they need to be, and it's within all the margins of error they need to be. So this is a great example where you could not use traditional methods of surveying and using a UAS to do whatever he needed to do to get the correct the slope of the hill on the side of the freeway. So pavement is another area we're getting into. So Jamie, he can talk more about this. He actually flew a very long distance to look at pavement that was being put down on a new road area. So this is a testament of what you can do when you really push the aircraft and the photogrammetry to its limits. So another example of some more stuff that we do here. This is a salt barn. So the folks that aren't blessed with the snow like we are in Ohio may not have this problem, but we've got salt barns all throughout the state of Ohio that we're constantly putting it out during the winter months, then resupplying it during the summer months. So a lot of the folks have asked us to do some salt barn calculations, in which we're in the business of doing that now as well. Some quick ROI on some surveying, and this is just an example of a terrestrial laser scanner. We've got other examples we're working to. So the current cost for a terrestrial laser scanner to do 1.5 miles of road is $19,000. So we've calculated the cost for us to do 1.5 miles with a drone is $2,264.65. So that's a saving of $15,118.30 every time you're doing it. So this is kind of a quick calculation. It's also a conservative calculation too. So as I mentioned, we're working on other calculations as well, but just kind of gives you an idea of what when you can substitute a UAS or a drone, the savings that can be had are tremendous, and it's something we all should pay attention to.
We have David. We have a question about the current state of the information for GIS. He said traditionally they have been accurate to the county level, but highly inaccurate to the towns and individual parcels. Do you think the UAS program helps with that?
I think it does. We have, as I mentioned, we've got 5 surveyors currently trained. And when I talk to a surveyor, they say they're very pleased with the level of accuracy that these aircraft can provide. I mean, I think a lot of it is in the way they capture the data, and a lot of it's in the way they put the ground control points in and the way they fly the aircraft and process it. Jamie could probably speak to more of that as well because he works more with the surveyors, but I've got 5 guys trained. I've got about 5 more that are interested in joining our program. So, with COVID and things like this and not being able to hire folks, a lot of our surveyors are retiring, and we can't backfill some of those stuff. So a lot of the surveyors are telling me this is the answer for them to increase efficiency, increasing the amount of survey work they can do. Because the way that they do with the aircraft is a lot faster method of the way they're doing it. So they're very pleased with the current level of accuracies, and it's within the parameters that they need it to be, is what they're telling me. I'm not a surveyor. I can't talk specifically about accuracies, but what they're telling me is it's highly effective.
Okay, thank you. You have a compliment from Thomas saying, love the ROI stats, which I agree. I thought on your previous presentation was amazing. Jamie, why don't you go ahead with your presentation? David, in the meantime, there's a question about your savings. Savings shown include the initial cost of equipment or a separate cost?
I believe it's an initial cost of, I'll have to double check on it, but I believe it is the initial cost of purchase. Is that what the question was? Yeah, yeah. One of my colleagues is next to me here. He's indicating that was calculated in.
It was, okay. Do you see opportunities for private sector contractors to be involved in this kind of projects? What kind of requirements would you have for private contractors?
That's a great question. A lot of times, if it's over ODOT properties, when we require it, it's just a basic. Have they? Can we take a look at their? Are they licensed? Are they licensed to fly in the area? Do they? What kind of experience they have flying? Just some basic questions. How heavy is the air? What kind of aircraft are they using? Make sure it's a, something that's within the FAA regulations, and basically anything that makes sure they're following the FAA regulations is the kind of stuff we're looking at. We don't want anyone out there flying that doesn't have their Part 107 or hasn't been through some sort of training. So it's just kind of basic requirements, nothing too stringent, just to make sure we're dotting our I's and crossing our T's.
So I've been working at the UAS Center for about 1.5 years. Prior to that, prior to working at the UAS Center, I was a professional archaeologist. I started using drones in 2015 we have a lot of prehistoric earthworks in Ohio, so I was kind of taught myself how to do photogrammetry to model the the earthworks and historic buildings and things like that. And then when I came to the UAS Center, drones were really starting to get going here, and we have a district pilot that was kind of going out and doing a lot of the videoing of traffic and schools and the things that Dave was talking about. And one of the surveyors kind of was working with him and started asking the questions of kind of knew about photogrammetry and wanted to know if we could make models. Like, well, yes, we can make models. I know we can do that. And then he wanted to know, can we make them so that they meet our surveying specs? And I was like, well, that part, I don't really know. So it was kind of a little bit of a journey, but I can just a sneak peek that yes, we can make them to meet their surveying specs. So photogrammetry, for those that don't know, it's the capture of photographs. There's no scanning involved. It's a completely passive process. And set up the drone to mark out your project area. The software, the flight planning software will calculate exactly where the drone needs to go, what kind of spacing it needs, how often it needs to take a photograph. It's pretty autonomous at this point. You just kind of set it up, hit play, and it takes off, flies its mission, collects all the photographs, and you can cover a pretty large area relatively quickly doing this method. So the UAS that we're using for survey at this point is the Phantom 4 RTK. The big advantage that this RTK system has is that it can tie into the ODOT CORS network, the virtual base station, basically. Having that level of accuracy known for each photograph seems to be really helping out with the accuracies of the photogrammetry projects. We know that we've done a lot of testing with this. We know that the drone tied to the VRS is capable of getting X and Y accuracies down to 2 or 3 centimeters. The Z is pretty consistently at about 1.5 feet off. So that's where the ground control targets come in. So we work directly with the surveyors. We don't touch any of the surveying equipment. We'll kind of give instructions on where we think the best places to put the ground control are. We'll set out our targets. Surveyors will shoot in the targets. We've been using the black and white squares and grass and vegetated areas. We've kind of gotten to painting targets on asphalt. Usually, we've found that pink seems to be the best for targets. And then we'll usually pound a mag nail with some blue ribbon taping into the center. And that combination of the pink paint with the blue ribbon makes a really nice target. It's really easy to see the center and mark all the photographs. And so when I first started at the UAS Center, the University of Cincinnati had been doing a research project with ODOT and the UAS Center to kind of figure out how UAS can be used with ODOT. One of the things that they were tasked to do was figure out if UAS could be used in surveying and what kind of accuracies they could get. They were starting off with no UAS experience. They were having issues with, how best to fly the UAS, how best to do the ground control. But what they were really good at doing was analyzing the data. So once we started collecting the data and flying the UAS at the UAS Center, and we would send the data to the University of Cincinnati to kind of determine if it was accurate or not. And it turns out it is. So this specific slide is showing the amount of ground control points for one project. So as it turns out, with the Phantom 4 RTK connected to the VRS, if you have 3 ground control points or 14, it doesn't improve the accuracy of the model. And to date, we have 4 surveyors out. We've done probably, I would guess, around 30 projects. At this point, 3 of the surveyors are out collecting their own data, setting their own ground control. They send me the photos to do the processing. And then they do their own accuracy checks on all of the data that we send back to them. And I would say in the 30 projects that we've done so far, every single one of them has come in with accuracies under the surveying specs. So they all want to do their own accuracy checks. None of them really believe the accuracies are there until they see it for themselves. So they all come along, and now they're doing this a lot more because surveyors in Ohio, I guess in the United States, is kind of becoming very short-handed. They're having a hard time getting the projects done with the amount of people they have to do it. So they're really relying on the UAS to help them gather the data in a very quick manner, especially compared to traditional surveying methods. They've come around, they know it's accurate. They still do the checks for each project. And it's being used more and more now. So just a real quick how photogrammetry works for those that don't know. So the idea is to get photographs that overlap each other. I like to have overlapping photographs of 80%. So one photograph will overlap the photograph beside it by 80%. And that way there are common points between each photograph.
Has ODT been affected by the federal government restrictions on DJI products?
Currently we have not been asked that. We do have some security concerns inside our Department of Transportation. We're kind of trying to work through them and sort through them about specifically the flight logs and where they're going. So there hasn't been anything at the state level that's banned them yet, but it is something that we are filing very close and something that we're concerned about.
And how about the software analytics, predictive aggregation? Do you use a specific software brand?
We use Pix4D and we use Bentley Content Capture.
Well, we took the time to answer some questions, so don't worry about it.
So most of the projects that the surveyors are wanting to do so far are like culvert replacements and intersection work, but we have gotten into some pretty dramatic terrain awareness flights, like this one. To give you an idea of just how big of an area that is and the amount of terrain involved, that the excavator is sitting on the side of the slope, basically at the edge of the cliff. So the processing part, so when I started at the UAS Center, one of our biggest issues is that we did not have a computer capable of handling the amount of data that we were getting. Very computer intensive to do the photogrammetry process. So after a lot of nagging on my part, IT finally broke down, and they gave us basically a processing server that has 6 very high-end computers connected together. So on those computers, we use context capture and Pix4D. So we found that Pix4D does really well with the small surveying type projects, the culverts and things like that. Seems to make the best Ortho Mosaics. But it's not the best software for three-dimensional objects like buildings and things like that. So for that, we use context capture. Context capture seems to do a really good job with 3D objects. And the other advantage that context capture has over Pix4D is there doesn't seem to be a limit to the amount of photographs that can be input in the context capture. So the Springfield-Beckley Municipal Airport is a project we did last winter. We sat on this data set for over a year because we just didn't have anything to process it. But in total, we surveyed 1,000 acres. We used 3 Phantom 4s to do it. with this 1,000 acres at 2 centimeters resolution. And then we surveyed each runway at around 0.8 centimeters resolution. Ended up collecting 24,000 or so photographs. And that's all the photos for the project that you see in the upper right. We were able to process all of that on our processing server. I didn't process all the photos together. Did it in sections and then combined it all into one project. So we're capable of doing a pretty large area processing, flying, all the stuff relatively quickly. If it weren't for the planes that wanted to land at the runway, we could have collected all of those photographs in one day. We had to stop and start and stop and start, and ended up taking us 2 days. The project on the bottom, the SR-79 washout, kind of shows the details that we're able to capture in the modeling process. So we can do a large area as an overview area, and then get down and take close-up photographs of a very specific spot. And the software can create the very detailed model, 3D model of that washout. It's one of the highest detailed models I've seen. And I will just mention this, that we do have a UAS LiDAR unit. It is, I would say it's in the early stages. We've worked out most of the kinks with it. But what we're finding is that, and for our specific unit, it's not as accurate as the photogrammetry on things like pavement, hard surfaces. It's just, the accuracy is just not as high. It's not as consistent either. But what it does do that photogrammetry can't, I say the kryptonite of photogrammetry are trees. So since taking photographs, it's a passive process. It can't penetrate through vegetation. It can't get through trees. But the LiDAR can allow us to get through the vegetation for hard surfaced areas. So we've been using it a lot for environmental type stuff, like wetland delineations, and we're going to get into doing some my old stuff, the archaeology with it, and then getting into areas of heavily vegetated areas that for survey type stuff. I don't ever see us going with the LiDAR unit, at least this specific LiDAR unit, to do like road surveys, but we still have a use for it. And that is the end of my presentation.
Okay, why don't we, Jamie, we have a few questions here. They're very technical regarding what you do. How much site control do you set for the 1.5 miles of drone topo used in the recent savings example?
So we did do an 8-mile section of road, and we sent the data to the University of Cincinnati, and they found that the same 3 control points basically gives the same accuracy. So what they found was if we had one control point about every half of a mile, you could get the same accuracies as having. So for the 8 miles, we put one every 100 meters. So if we use every like 30 control points per mile or 3, it gave the same accuracy results.
Yeah, the other one is an overkill.
Yes. So that's what the Phantom 4 tied to the core system. If you're using a drone that wasn't tied to the core system, or if we use the Phantom 4 without being tied into the VRS, I'm not sure that would still hold. But as long as we're tied into the VRS, that seems to be the case.
What altitude you normally fly for photogrammetry?
It depends on what kind of results we have. So we generally try to stay between the 1 and 1.5 centimeter resolution. Mainly staying at that resolution to ensure that when we tie in the ground control points, it's as accurate as possible. So what we have found is the density of the point cloud doesn't really affect the accuracies of the model. But if you get, I know it sounds crazy, the difference between 1 centimeter resolution and 2 centimeter resolution doesn't sound like much, but when you're actually tying in ground control points, it makes a big deal. It makes a lot of a difference. So if we want to keep those models as accurate as possible, try not to get above 1.5 centimeters of resolution.
It's exponential.
So, yeah. So for our Phantom 4, that's like 120 feet, like 40 meters high.
Okay. What software do you use to fly and then process?
So for the Phantom 4, it actually has a built-in screen on the controller. It's specific for the Phantom 4 RTK, and it's probably the best flight controller that we have. So we use the UGCS for the magnetometry surveys. We use all the other DJI software, flight planning softwares, but the one specific for the Phantom 4 RTK is different than all of those. And in my opinion, it's the best one, and we have not been able to get it to work on any of the other aircraft. We've tried and failed, but.
So is the nature of this business.
Yes, yes.
Do you photograph 2D or 3D oblique for photogrammetry?
For just looking for like ortho imagery, it's almost always just 2D oblique. If we got into like some facility mapping projects where they wanted to see models of buildings, and the Phantom 4 RTK software actually has a 3D mapping aspect built into it, where it will take cross section, like it'll do like a cross paths, and it will have the camera at 70 degrees angle. That helps with getting sides of buildings and sides of water towers or whatever. For flying, like for the salt barns that Dave was talking about, actually fly the UAS within the building. I take all those by hand, just manually pulling the trigger. And if I want to do like the modeling of a bridge or that washout, I do it by hand. It's just kind of what I've got used to doing. When I started doing it back in 2015, just kind of flying really close to things by hand. It's really easy to mess up doing that, not getting enough photographs, but a lot of trial and error, and kind of figured out generally I can get models to turn out well.
There's a question about large area topographic surveys completed on multiple days. Do you have problems joining the databases from different days? If so, what strategy do you use to solve them? I remember in conventional photogrammetry, what we worry about different days is the light. You can fly one day with great light and beautiful, and then the next day is overcast. It's still acceptable, but the photographs are going to be different. What's your experience?
Yeah, that still holds true. The lighting seems to be the biggest issue with multiple day projects like that, or even projects that take several hours. In general, the software, Pix4D at least, does a pretty good job of kind of blending the different light and shadow things together. When it really becomes an issue is if we're doing photogrammetry with thermal cameras. There'll be a big stripe of area that has where the temperature suddenly drops because a cloud went over from another spot.
Right.
As far as the accuracy parts, as long as we're tied into the VRS, it doesn't seem to matter. I know when I was doing archaeology projects and I wasn't tied into the VRS, and we weren't really worried about getting the survey accuracies. Doing something like over multiple days would cause issues with getting the photographs to line up and make a consistent model. But as long as we're tied into the CORS network, it doesn't seem to have an issue at all.
Okay. There's someone here who wants to see if you have tried the UAS Master from Info Trimble?
We have not. So our CAD mapping department is trying that. We've had a bit of a rough road, I would say, with some of the surveyors not really believing that we can use UAS and get the accuracies necessary.
I was one of those.
Yeah. Well, we still have them. So the surveyors that are doing it, they had to see it to believe it, and some just don't even want to see it, it seems like. But I know they're trying it. They were trying to do some things on their own, and they were having some issues. I don't know how it's working out with the Trimble software.
Okay. The last question we have is, what LiDAR units are you using for the drone work?
So that's a Quanergy M8 from LiDAR USA. It has the Velodyne pucks are in there. I believe there's 6. The biggest issue that we have with that unit is that it makes, it's called like a fuzzy ground, like a hard road won't be a consistent plane. It will be a fuzzy, 6 inches of points will be in there somewhere kind of data. That seems to be the expected results from that unit. So we've tried a lot of things to clean that up, and we've kind of settled on a voxelation tool. It makes basically a 3-dimensional square, a cube basically, and we'll find the average X, Y, and Z within the set parameters of that cube and produce a point for that. It thins the data out a lot. It gets rid of the fuzziness, and it also, if we have enough points in there, then finding the average, it gets pretty close to what the accuracy should be, but it's still not there. It's still not as good as the photogrammetry.
Okay. The last question before we move on. Drone to map by ESRI is what our GIS staff is promoting. Have you had any experience with it? My experience with GIS staff is they always promote ESRI, but that's my experience.
As far as I know, the Esri mapping or photogrammetry, they're using Pix4D in the background.
Yep.
So yeah, you're just getting the same results that you get out of Pix4D. So what we found is that our surveyors use MicroStation a lot, and MicroStation has a really hard time handling large TIFF files. So we've been using the Lizard Tech software to convert those TIFFs into SIDs, and really cutting down on the size, and they seem to be able to pull the data in better.
Okay. Thank you very much. Thank you, David. Thank you, Jamie. We have 15 questions, so I'm happy we did this.